All right. So, welcome to the networks course. Either for some of you, it's course C480, and others, it's D325. Welcome to the networks course, Routing and Routing Protocols Cohort. My name is Adrian. I am one of the course instructors for the networks team. I'm also a course instructor for several other teams, but this is really one of my pride and joys. I really like networking, and I hope that I'm able to relay some information that you will find helpful and actually make you more successful on your Network Plus examination. So, our objectives for this particular cohort are to discuss. First, we want to discuss what are routers, guys. So we hear this term routers. Sometimes I hear gateway, sometimes I hear default gateway. What is this thing? So we want to talk about what a router is and what it does. Then we want to discuss what are routes. So if we need to know what a router is, we definitely need to know what a route is, because we can't really understand truly and earnestly what a router is without understanding its primary function, which will be to provide routes. But what is that? All right. We're also going to discuss how routes come about. How do routers know how to get places? I mean, are they magical? No, not really. That's where the next topic comes into play. We're going to be talking about routing protocols. And within the routing protocol categories, we're going to discuss distance vector protocol routing protocols, link state routing protocols, and hybrid routing protocols. Then we'll talk about routing metrics because, well, routers use routing protocols to talk to each other. Think of it as the language of routers. But even within the language, we need to have some rules, right? Every language has a set of rules that govern the communication. So within these rules, there's going to be certain things we do in a certain sequence. In this case, there's going to be certain metrics we need to consider in order to find the best possible pathway or route to a destination. So we're going to talk about the metrics for RIP, which is Routing Information Protocol, EIGRP, which is the Enhanced Interior Gateway Routing Protocol, OSPF, which is the Open Shortest Path First Routing Protocol. And then we're going to talk about a very special metric that only really comes into play when we start comparing these routing protocols to each other. Because when we compare a RIP route with another RIP route, well, we're going to use its metrics. But what happens when we need to compare a RIP route to an OSPF route? Uh-oh. Which one should I choose if they both point to the same direction or destination? Oh, that's where administrative distance is going to come into play. Think of it as, I'm going to be the factor that decides which of these routing protocols is going to be right for you when you have both configured. Then we'll talk a little bit about configuring a static route. Okay, let's go. All right, so first up, guys, what are routers? So routers, as we said, also called gateways or default gateways or layer 3 devices, are actually networking appliances that will allow you to connect two or more networks. Okay, these packet switch networks, we may say, hey, my local area network and my service provider's network. Most of us are not connected directly to the internet. Although you may think so, you're really not. You're connected to your service provider's network, and your service provider network is connected to, well, other service provider networks, which are connected to backbone networks. That's really how it works. So the internet is just a big collection of networks. Now, what's making these connections though? Still, it's routers. Routers allow the communication of packets or the forwarding of packets from one router to another over, well, what we would consider an IP network, whether it be IP version 4 or IP version 6. Now, when routers come into play, guys, they're going to have two major functions. Number one, they're going to manage your IP traffic between the networks by forwarding these packets based on the actual intended IP destination address. So every packet is going to have a source IP address and a destination IP address, very much like when you guys send a letter, an actual snail mail letter. I know, boring, but it has a sender address and it has the destination address or receiver address. Now, the other use or function of a router is to allow multiple devices to use the same internet connection to reach other networks. Like, for instance, in your home, you may have a wireless, let's say, laptop, smart TV, smartphone, tablet, and the list goes on and on and on. So how is that I only need one router, one single solitary router to connect to the internet? I don't need a router for each one of these devices? No. So routers have a very special function or feature known as network address translation, where on the inner side of the router, your network, we'll pretend like this is the inner network. Let me grab my little annotation tool here. So let's say your network's here where your tablet and your smartphone and your computer's here, and it's going to have a private address. Okay, so typically we have private IP addresses such as 192, forgive my horrible scribbling here, .168. Yeah, this is always hard drawing with these guys. .1 whatever, right? So you have the private IP address back here. But to get to the internet, you're going to need a public address. Notice this address here. I know some people are saying, that's Class B. Good for you. You recognize Class B because of this. But I hope you also recognize this is Class B public, not private, because of the second octet. Remember, if the second octet is between 16 to 31, then it's private. But since this is not the case, hey, this is a public Class B. So your router is going to have an address on that. It's going to have a single address here and a single address here. But what's going to happen is your router is going to say, if anything's coming from this network inside the router, he's going to translate it. He says, I'm going to twist it around and change it into a public address, or at least make it look like so. Okay. He's also going to keep a record of it so that the outside world will only see your single solitary public address, which is known as network address translation. So that's one of the functions of the router, to allow multiple devices to use the same internet connection through a feature known as network address translation. We just like to say NAT. As most network people, we love acronyms. All right. I think that's good enough. All right, so let's talk about what layer does a router fall on? Well, because routers make decisions based, we said, on source and destination IP addresses, routers are typically considered, wait a minute, IP address, also known as the network address. Oh, the network layer, layer 3 of the OSI model. That is the network layer. And so when you look at layer 3 of the network model, we know that the network layer makes decisions, what we call routing decisions, based on IP addresses. Okay. Now, some multi-layer switches can also function as routers. So be aware, there are some special switches out there known as multi-layer switches, and there are even some servers that can fit in this role, but mostly multi-layer switches that can serve as routers. Why does that even exist? Why is that a thing? Well, here's why. Not every organization is a big million or billion-dollar corporation. Not every business makes even hundreds of thousands of dollars. Some organizations make only a few thousands of dollars a year. So they can't really afford to have a lot of the high-end devices. So instead of buying a switch and a router, they sometimes buy a multi-layer switch, which gives them both features within the same box. All right. So what are routes and how are they created? So we talked about what routers are, but we really haven't talked about what routes are within routers. So essentially, the route is nothing more than a path or direction that is taken to leave from some starting point and arrive at a particular destination, just like the definition says here. Wait a minute. I've heard the word route somewhere else. Let me see. Oh, have you guys ever used GPS or the map application on your phone and maybe even gone the wrong direction a time or two and it says rerouting? Well, your GPS essentially is a router of sorts that's telling you how to get from wherever your starting point is to arrive at a particular destination. Well, routers are basically the GPS of the internet. That's what they do. Okay. Now, that destination can be on the internet, or maybe you have multiple networks and you need to reach resources on other networks. Maybe you even have multiple locations. So your routers are really going to, well, store the information about these pathways from different, or I should say, two different destinations. Routing is the process of selecting the best, notice I said best possible path for your IP packets to actually travel from the source to destination. Okay. So that's something to note, is that when routers are routing, basically they're choosing the best possible path. Sometimes this path can take you across multiple networks. Well, what do I mean by that? Well, when I say across multiple networks, I want you to imagine, once again, I apologize for the horrible drawing. I'm not Picasso, or maybe I am, Cubism, all right? But imagine this is your home, okay? Okay, I know it's horrible, okay. But now you need to go through your service provider to reach the internet, to reach Google. Well, look at this, guys. Within the internet, there are other service providers. There could be one or two other service providers within the internet, because we don't know who Google's service providers are, although Google is, I think, their own service provider now. But there needs to be a connection all the way back here. Guess what? Inside your home, you have your own network. But between you and your service provider, there's a network. Between your service provider and maybe another service provider, another network, and maybe more networks within there. And then it'll serve a network between Google and their service provider, which may be them. So, and then of course, there's a network inside of Google. And we're trying to reach that single computer in Google. So wait, we may need to travel across 1, 2, 3, 4, 5, into the sixth network. So our routers are giving us this information on how to reach certain locations. Now, will it have direct information about how to get directly to Google? Probably not. But it's going to say, hey, if you need to get to Google, you need to go, well, send the packets toward the service provider and they'll take care of the rest for us. So routes, though, are generated in one of several manners within our routers. So how did your router get that information? How did it know to even send it to the service provider? In the onset, routers are blank. Yeah, they don't know anything. But Your router, most likely, once you plugged it in to whatever your service provider's network was probably set up for DHCP, meaning your router said, hey, I'll accept whatever information is provided to me by the service provider's router. So when you did that, your router learned a route dynamically. Well, that's not my laser pointer. There we go. Dynamically. So routes can be learned by dynamic information, which is updated or shared from other routers. Basically, routers are going to use their own special language, known as routing protocols, to share this information with one another, or at least with their neighbors, which mean the connected router. Also, you guys could go in and manually enter that information. This will be known as a static route. Now, if you're going to manually enter it, I hope you know what you're doing. Otherwise, you may end up black holing your entire connection to the internet. Black holing means you send it into nowhere. That's exactly what a black hole is going to do. Okay. But your router also, the moment you configure, let's say, your router to have a particular IP address on one interface, that router joins that network, and that's known as a directly connected route. So 3 ways: directly connected routes, static configuration by you, and dynamic updates. So speaking of dynamic routing and the language of routers. So routers use what's called routing protocols for that dynamic updating so that they can talk to each other. So when we talk about the routing protocols, there are going to be some primary categories that we want to look at. There are 2 primary categories to start out with, and they are exterior gateway protocols, meaning routing protocols that happen between 2 different entities, like, well, you and your service provider, your home network and your service provider can be using, well, exterior gateway protocols. Most of the time, it's not. You're going to most likely just be using, because your system's going to accept an IP address from your service provider, it's not going to be exterior. But what about between Google and Amazon? Oh, well, hey, if they want to communicate with each other, they could be sharing an exterior pathway between one another. That makes sense. So I got some good news, some interesting news about exterior gateway protocols. There's only one. Yeah, I know. So why did they use the word protocols? It should just be exterior gateway protocol. But that's because there used to be an actual routing protocol called exterior gateway protocol. But now, these days, we only have the one exterior gateway protocol. It's known as border gateway protocol. So that's interesting because when you look at the definition of BGP, it will say it's the routing protocol used between autonomous systems. What's an autonomous system? Oh, that's just 2 different entities, or it's a singular entity that is in control of their entire network. That's all it is. Google is an autonomous system. Amazon's an autonomous system. Microsoft is an autonomous system. Not everyone is an autonomous system. Most customers, when I say customers, I mean consumers, are going to be just members of an autonomous system. That autonomous system is usually your service provider, which is why you're not using a border gateway protocol at your router to your service provider's router. Unless you opt in for, let's say, business class networking, then business class, you may actually become an autonomous system. Uh, it's going to cost you more, though. That's the trick. Now, let's look at the other category. The other category of routing protocols is going to be, for us, the interior gateway protocols. Now, IGPs, this is where the bread and butter for the exam comes in, because you're going to see more questions about these, whether they be questions, whether they be PBQs. You'll see information about these in the exam because this is what we see more so on a daily basis. Now, for interior gateway protocols, there is the routing information protocol, which is the oldest. When I say old, guys, this guy is probably, oh, he's about 30 some odd years old. Yeah. Okay. He was the first routing protocol, RIP. So when I see RIP, I always think of Rip Van Winkle or rest in peace, because no one wants to use RIP anymore. Then there is OSPF, open shortest path first. We'll talk about what that really means. Well, I'll talk about it now. So open shortest path first sounds like it's saying pick the shortest path first. Well, in a way it does, but that's not why it's called that. Open means open sourced. Okay. So no one owns the right to OSPF. It's under the open source licensing. So the shortest path first part, though, is interesting because it's based on a very special mathematical algorithm called the Dijkstra's algorithm. I know. The Dijkstra's algorithm says, I want to find the fastest pathway. And the faster the pathway, I'm going to assign it a very special value. We're going to call it a cost. Okay. So the faster the pathway, the cheaper the cost. That makes sense. Then there's the enhanced interior gateway routing protocol. This guy is very special because it's proprietary. It's owned and it was created by none other than Cisco Incorporated. Cisco Inc. is one of the, if not the biggest networking company producing network appliances and softwares and technologies, well, in the world. So it's only right that they create their own routing protocol. Now, here's the thing. Other routers from other vendors, whether it's Vios or Adtran or Adva or you name it, they're not going to really have EIGRP as a function or a feature because you got to pay a license fee to Cisco to have this on your router. And a lot of companies say, we'll go with the open sourced one. Yeah, that's. Now, these two protocols, although they're different, they have some similarities. We'll discuss in a moment. Then there's another interior gateway protocol, which you guys don't get exposed to very often or very much in this material or exam, and it's known as the intermediate system to intermediate system, ISIS. This one is a protocol that is primarily utilized within service provider networks, which is why you guys don't get exposed to it very often because it's open sourced, but it is very special purpose in its use. So it's not so much of a big factor for you, but we'll talk a little bit more about that shortly. Now, when we talk about the interior gateway protocols, which we just went over, the big four, the only four really, there are two categories that they can fall into, okay? The two categories, or I should say two primary categories, although there's going to be a third category. The two primary categories are distance vector and link state. Now, here's what you need to know about distance vector. Look at the words distance vector. Distance vector means I'm going to choose the pathway vector, aka direction, I'm going to go based on the distance from me to the destination. Now, what do we mean by distance? So the one and only legacy routing protocol, RIP, uses a distance vector protocol, uses a distance vector measurement called hop count. What does that mean? Oh, let me grab my horrible annotation. Sorry, I got to draw again. So between, let's say, one router to another router, as packets are leaving, that's known as a hop. Okay, so really it's looking at the number of routers between the source and destination. The more routers, the worse that path is, at least to RIP's imagination. So if there's more routers between a source, a starting point, to a destination, then the router's going to say, well, unless there is an alternative path, I'll take this path. But if there's an alternative path, let's say from this router to this router to the same destination, well, that's a single hop. But where's the catch? There is a catch, guys. The catch is, what if this pathway with 3 routers was super fast? Wouldn't you want to take the super fast one? And let's say this one is super slow, like really slow, like 10 megabits per second. Oh no, you won't be streaming Netflix on that. And this one, let's say, is, oh, I don't know, 1 gigabit per second. So even though there's more routers, it's a much better path because it's faster. Yet RIP will say, nope, we're taking the path with the shortest number of routes, or hops, I should say. It doesn't take into account the factor of speed. It doesn't care. It says, I'm choosing your vector based on this distance measurement. And that measurement is the number of routers between the source and destination, better known as hop count. Now, the other category is link state. And link state is a lot smarter, okay? But link state came a little later. So, so the link state protocols are OSPF and intermediate system to intermediate system. These two actual routing protocols will look at the speed instead of the number of hops. But they also, luckily enough for us, are smart enough to make recalculations. Let's read our 2 paths again. Okay, and let's say this is the destination here. I'll make it look more like a building, I guess. It's not really, it's a horrible building. It's falling apart, it's splintering. All right, so let's say we have 3 routers to get to the destination, and an alternative path with 2. But once again, let's say the top path is 1 gigabit per second. And the lower path is, 10 megabits. Let's make it a little faster. 100 megabits. It's a little better. Not by, oh yeah, it's a lot better actually. Some people are right now using 100 megabits, so it is better, much better. And yes, you can stream Netflix now, but it's not as good as that gigabit, not at all. All right. So anyway, with OSPF, it'll say, hey, this is the fastest pathway, so let's go this way, so that the traffic can reach its destination faster, which means you get the feedback or results faster. But whoa, let's say this pathway, something happens to it and it gets disconnected somehow, damaged. Well, OSPF says, okay, what are we going to do? What are we going to, no, it says, okay, that pathway's out. How does it know? Well, the routers talk to each other. And when the router, this router right here, okay, says, I can't communicate, or I hadn't heard from this other router, he's going to send a message back to the starting router, which will then send a message back to you saying, we got a problem. We need to recalculate another path because the pathway's out. The bridge is out. So we'll take a detour through the alternative route. That connection between routers that's out is known as a link. So OSPF and ISIS are always monitoring their connections known as links. Henceforth, they're concerned about the link state. All right. So when we look at these 2, then we say, Those are pretty intuitive. But there's a third one. The third category is if you would take the best of both worlds and put it into one package, and its name is da, 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 EIGRP. But wait, he's owned by Cisco. So we can't, if I don't have Cisco routers, I really can't use it. Yeah, I know. But this is why Cisco is still one of the dominant leaders of the networking world because they innovate so well. So it may be worth it to buy that expensive router, but it's up to you, the company, right? The bottom line. So the distance vector and link state rolled into one becomes EIGRP, but it's going to use some interesting pieces to make up its base decision. Now, these categories will always, okay, be different in their metric values. Yeah, they are different. We just talked about the fact that OSPF and ISIS uses speed to choose its best pathway. RIP uses the number of routers, and EIGRP, you won't believe it, it's going to use a combination of these things, right? And it's going to say, hey, you know what? I want to know the speed. I want to know how reliable. I want to know how much am I sending. And yeah, so it's going to really add, and I want to know the delay, by the way. I want to know if there's any delays along that pathway. Does it slow down somewhere? So these metric values are different. So we can't easily compare these with one another without there being another special calculation or value, which we're going to talk about. It's called administrative distance, by the way. All right. So speaking of those metrics, so we've already discussed that RIP uses hop count. What's hop count? That's really a fancy way of saying how many routers between you and the destination. A hop is actually when you enter a router. I don't want you guys to think when you exit a router. So let's say from your computer, this is my horrible laptop. Oh yeah, that was a horrible laptop. It's like a tri-screen laptop. Anyway, so going from your system to a router, that's a hop. Going to another router, that's a hop. But then when it leaves there and goes to Google, well, it's really going to go to Google's router. That would be a hop as well. But from Google's router to their, let's say, server, oh, I'm going to draw that server. Almost made a square. Almost. Rectangle. That is not a hop. Okay. To the server, that's not a hop, guys, because that's from a router to a device. That's not going to be a hop. Hop is always going to be going into a router. So 1, 2, 3 hops. That's it. Okay. Now, RIP, remember legacy. RIP bad, right? No one wants RIP anymore. EIGRP, we'll swing back to it. OSPF and ISIS, link state, they like the path speed or the link speed, meaning the link, remember guys, is the connection between the routers. Okay, so it's really calculating and saying, hey, what's the speed between these? So if this is 1 gigabit and this is 1 gigabit, then it says, well, the whole thing is a gigabit. So as far as I'm concerned, I'm going to associate that with a specific cost. It's going to give it a cost, okay? So there's actually a chart of cost, which I don't really think you really have to know the cost per se for the actual links, but just know the faster the actual bandwidth or higher the bandwidth, the lower the cost, the more preferred the path is. The higher the bandwidth, well, yeah, the higher the cost. So if we had an alternative path, even if it was, less routers, let's say that's 100 megabits, well, that's going to be more expensive. So if you go into a store, think about it, and you see two identical items and everything's identical, but one is $10 cheaper than the other one, which one are you going to buy? You're probably going to say, hey, is something wrong with this one? Because it's cheaper. And they say, no, nothing's wrong with it. Then you're going to be a little confused, but then you're going to probably decide to buy the cheaper item, cost item, but you're going to get exactly what you want. Well, that's what that means by applying this cost. We're going to have two or more pathways sometimes, not all the time. But if we do, we're going to choose the one with the lowest cost, which means it's the path with the fastest speed. I always think of it in terms of gas. If I can get there faster, I may burn less gas. All right, now let's swing back to EIGRP, EGRP. Now, with EIGRP, which is Cisco proprietary, they're going to use the following 5 metrics. It's also called composite metric. Composite because it's made up of multiple metrics. They're going to use a reliability check, the bandwidth, which is path speed, the load, how much data you're sending, the latency, the delay. So if there is a massive delay, okay, let's say 2 pathways to the same destination. And I should move that over a little bit. Oh yeah, that was horrible. I want to do over. All right. I really wish they would have shapes. I could just do a shape. All right. Let's say 2 pathways, same destination from your home that your router could take. Okay. Well, if they had the same speed or bandwidth and you're deciding to send the same amount of data, let's say this pathway has a delay though. Let's say, you know what, I have a delay of like 7 milliseconds. And the delay here is only 3 milliseconds. Oof, that's a big S. All right, so that would be the path we take. Because it's less delay. It's just like when you choose to travel somewhere in your vehicle, and if your GPS says, oh, there's a delay on Highway 101, alternate route is Highway 102. Depends on the delay. If Highway 102 would normally take you 3 more minutes, but the delay on Highway 101 is going to be 10 minutes, yeah, you're probably going to go the alternate path. Okay? So it's going to look at all of these things. And as an added bonus, how much data can you usually send in a single packet? Which, guys, maximum transmission unit for most of the time is going to be 1,500 bytes. FYI. So if you say, hey, what's the MTU for a standard packet? 1,500 bytes. Okay. Sorry, if I could use my pen, it'd be much better. Anyway, last but not least is the one and only, you know it, Exterior Gateway Protocol. That's BGP, Border Gateway Protocol. It's the only one for exterior autonomous system to autonomous system. And it has a massive list. It actually has 10 metrics it could use. Normally we use 6 of these 10, such as weight. That's really how much data you're sending. That's like load. Local preference, meaning you've actually set a preferred path where it's originating from. Autonomous system path length, origin code, and the med. Wow, that's a lot. But luckily, you guys don't need to know that. Not until you decide, hey, I want to be a network engineer and I want to go get a Cisco CCNP. Then, yeah, you got to learn this. All right. So let's talk about the other measurement that we will use in the event we get two pathways to a destination, but each pathway was given to us by a different routing protocol. How do we compare OSPF to ISIS to EIGRP to RIP to static configured by you to directly connected? So when we want to compare routes to each other from different routing sources, we're going to use what's called the administrative distance. So let's say, for instance, I get a route from me to Google, and I'm getting it from RIP. And I also get another route from me to Google through OSPF. And I get a third route from me to Google from EIGRP because I have a Cisco router apparently. And I've enabled RIP, OSPF, and EIGRP on the router at the same time, which you can do. Which one will I take? Uh-oh, that's a mystery. No, it's really not. So here's what we're going to do. We're going to see which ones we trust more. So when we talk about administrative distance, we're really talking about trustworthiness. And for that, I always refer to my circle of trust. All right. I don't know if you guys have ever seen the movie Meet the Fockers, but I love that phrase. Anyway. So the circle of trust is simply saying the closer you are to me, the more I trust you. Well, you can't get any closer than 0. Spaces away from me. That's like super trust there, guys, right? But, one step away, there's still a lot of trust there. So a directly connected route basically means a router's interface with an IP address is the most trusted you can be. It's an administrative distance of 0. That's how far away trust-wise you are. But if it's a statically entered route by you, the administrator, well, the router's not going to trust it as much as its own interface, but it will trust it enough that, well, it will trump most other routes. It's going to give it an administrative distance of 1. And pay no attention to EIGRP summary right now. You guys won't be doing any summary routes. BGP external, or BGP, it's going to have a trust of 20. Let me put some circles around this. The ones you really need to pay attention to. All right. But back in that situation, I said I learned about it I had OSPF, RIP, and EIGRP. When comparing that, EIGRP, which is normally what we call EIGRP internal, it's going to have a trust level of 90. Whoa, that's a long way away from the circle of trust, isn't it? But wait, I also say, what if this is the old version. EIGRP used to be known as IGRP. This is still Cisco. We no longer use this at all either, okay? Because Cisco replaced it with EIGRP, so we don't care about that, all right? So if you use OSPF, you're going to have a trust level of 110, ISIS 115, and RIP 120. So I'll ask my question again. If you learned about a route between source and a destination from EIGRP, also another route to the same destination from the same source by OSPF, and a third route from the same source to the same destination from RIP, which one would you trust more? And therefore, which pathway would you choose? And I'm hoping you guys are saying EIGRP because it has a trust level of 90 when compared to OSPF's 110 compared to RIP's 120. Remember, the name of the game here is how low can you go? The closer you are to zero, the more trusted you are. All right. Now, there are other actual routes, protocol standards that, and I don't want to do the unknown, that you'll see here in this chart, but you don't really need to know these. These are nice to know, but not necessary because they won't be on the exam. They're beyond the scope of this exam. Now, there is this one, though, that every blue moon, some option in the exam may show up. Don't know if it will or won't, but the highest level that administrative distance can be is 255, which means it's unknown and untrusted. That's a long way from the circle of trust. 255 is all the way out there, so we don't trust it. This is also how, if you ever read about route poisoning, this is one of those values that can be set to poison the route to tell other routers, don't go this way, it's bad. All right, now I wanted to demonstrate, and I think I got just a few minutes to see if I can do so. Let me check a network really quick for you guys. Let's see if I can do that. So I'm using a tool called Cisco Packet Tracer. Let me see if I can open up. No, that's 418. No, it's not too bad. I thought I had another one here. This is an example I created for the capstone class, but I thought I had, it's gonna bug me. Oh, there it is. I knew I had one. Da, da, da. All right, guys. So let me zoom out just a little bit from here so you can see. So I have a headquarters and I have a remote branch. And if I want to connect between them, and I have the internet here, so let's look at one of the routers just to see what information we can glean from a router. Uh-oh, looks like I clicked off. Hold on, back. There we are. Back, I tell you. All right, let me bring this back up too. All right, here's my router. So I'm just going to look inside of the router, okay? So don't worry, don't panic. You don't need to know Cisco commands to pass the exam. You just want to be able to understand things like when you look at a routing table, what's really going on, okay? So I'm going to show, oops, I don't know what my caps is on. Show my IP route. You guys don't need to know this command, but if you recognize it, it's how we look at routing tables inside of Cisco routers. And here is a routing table. All right, so when I'm looking at a routing table, on the far left, it tells me how my route was learned, okay? If I see the letter C, that means a directly connected route. If I see the letter S, that is a statically configured route. That means I put that route in there, okay? If I see the letter O, I bet you can guess who put that there, OSPF. If I see the letter E, I know, that gets weird. It's going to be placed in there by EIGRP. And you're probably saying, why not E? The answer is, well, when Cisco decided to create these, E was already used. Yeah, I know, that sucked. By what was by the original exterior gateway protocol. Before BGP, there was EGP. Yeah. So Cisco said, we'll use the letter D. Okay. Also, little useless trivia, there's an algorithm that uses all of those composite metric called the DUAL, which is diffusing updating algorithm, DUAL algorithm. Starts with a D, so they said, let's use D. Then there is, if you see an R, I bet you can guess what that means. It means route in peace. No, it means routing information protocol, RIP. And then, of course, there is the one for ISIS, which when you see ISIS, you're going to know it because it's the only one with a lowercase letter. That's weird. Everybody else has an uppercase letter, but that's okay. So long story short, when we look at the routing table, I'm seeing the route information, and let's walk through this. So it's telling me the destination, okay, network, that's usually what's on the left side, and then how I'm going to get there via, so it says via. Well, this is known as a next hop address. That's the next router in line. So to get to the 10.10.10.0 network, I will get there by sending my packets to the router with the IP address 172.1.1.2. Okay? Versus directly connected routes. Now, let me show you something else that's cool. You see the square brackets in between the destination network and the next hop address? There's two numbers in here. The number on the left side of the slash is the administrative distance. Wait a minute. Didn't we say the administrative distance of a static route is 1? Yes. Wait a minute. Is that true? Let's check OSPF. So down here we have a route learned by OSPF. Let's see. The destination network and the next hop. Okay. And it even tells me which interface I need to go out of. But look here. Dun, 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 dun. Wait, we said OSPF's administrative distance is 110. So if I had two routes, one learned by OSPF and one configured by me to the same destination, I wonder which one wins out. Let's see. Let's enter a route really quick. So let's go into the configuration mode and let's set a route. IP route, because I think I promised I would show you guys how to configure a static route. Although you do not need to know how to do this for the exam, okay? So IP route, and we'll specify the destination network 192.168.200.0/24. And if you say, hey, do I need to know? Wait, we can't do the slash in a Cisco router. We have to say 255.255.255.0, which is /24. And I'm going to get there via the next hop of 172.1.1.2. So I just entered a static route. Let's see if it's in my table. So I remember I had 1, 2, 3, 4 static routes. Let's see if I have a fifth now for 192.168. So let's do show us the routing table, IP routes. And here we go. So look, I have 2 routes for the same destination. Oh, that's a /25. I messed that up. Let's go back really quick and undo that. Say no. And let's redo it. Okay. Because I did the wrong mask. I said 255.255.255.0, which is a /24, but apparently it's a /25. I didn't pay attention to that, so it's 128. All right. So if my numbers are confusing you, please either see me or one of the other instructors, or please visit my team members' cohort on subnetting, because subnetting is very important, not from a sense of just knowing how to do it, but being able to understand what you're reading when you see routes, as well as other configuration information in the exam. There we go. Okay, so I should have a /25 now. So let's show us the route. All right. And wait a minute, there it is. So I have, wait a minute. Did you guys see that? What happened? I used to have 2 OSPF routes. One of them was for 192.168.200.0/25, wasn't it? But then when I entered a static route for the same thing, it replaced the OSPF because it was trusted more. That's administrative distance at work. How cool is that? Right? All right. I've taken enough of your time. I got about good 3 minutes left. I want to see if you guys have any questions. You can type in chat or you can come off mute. No questions? Oh, you're quite welcome. Well, if you guys don't have any questions, I'm going to give you back the time of about 3 minutes, 2 minutes and 30 seconds to be exact. So thank you. And I hope you will attend our next cohort, which I think there's one for subnetting coming up soon. And I hope to see you guys successfully complete the course soon. Take care.